Start recording. And some of you probably noticed this. I made a big mistake on the calendar. We go all the way to 4.9. But I didn't put that in the calendar. So I left off the section there. So the 2 days that I supposedly said buffer day, make them 4.9. So in other words, I'm not as far ahead as I thought. At first, I was under the impression we were only going to 4.8, but we are going to 4.9. We have some problems at 4.9. So, all right. So you can put 4.9 for these. That's not going to change the exam date. The exam will still be November 6th, it looks like. Okay. So I'm already up to 4.7. I'll do some or a lot of 4.7 today. Quick change on the homework also. Let's see. 4.7, I'm sorry, this is pointing to the wrong one. Should be 4.7, skip 27 and 29. Sorry about that. 4.7, skip 27 and 29. Okay. And again, for the little calendar, the 2 buffer days next week, make them 4.9. Okay. Ideally, I would leave Thursday for questions and answers. So I'm not that far ahead actually, but hopefully we'll push some days back. Friday is theoretically still a buffer day, so I think we're okay. All right, so let's go ahead and get started. Okay, so 4.7, we're doing these kind of things. The sine of a sum or difference, cosine of sum or difference, and how to do stuff like this. Okay, so I'll show you how to do those now. Okay, very quick summary of what happened yesterday. So I did talk about these yesterday. So just rehashing these, you should already have these. Or if you look in the video, they're already there. It's also in the book. So big identity, sine squared theta plus cosine squared theta is always equal to 1. Less well known, 1 plus tangent squared theta equals secant squared theta. 1 plus tangent squared theta, cosecant squared theta. You can put these on your cheat sheet. And formulas for sine of a sum or difference, sine of A plus or minus B, sine A cosine B plus or minus cosine A sine B. And the way you read it is you have the top symbol, you have the top symbol. If you have the bottom, you have the bottom. Otherwise, the formulas are the same. Please notice for cosine, they change. So plus gets a minus and a minus gets a plus. So cosine of A plus or minus B equals cosine A cosine B minus plus sine A sine B. So if you're using the plus here, you use the minus here and likewise here. Okay, the double angle formulas, sine of 2 theta is equal to 2 sine theta cosine theta. Cosine of 2 theta equals cosine squared theta minus sine squared theta. Again, put these on your cheat sheet if you wish. All right, and that just summarizes everything that I said there. Okay, and then the half angle formulas combine here. Cosine squared theta equals 1 plus cosine 2 theta over 2. Sine squared theta equals 1 minus cosine 2 theta all over 2. Okay, so put all of these in your next cheat sheet. And now I'll get started with some of the homework problems. Okay, and yes, I realize I might be going a little fast, but because I'm recording, you can always look back at the video. The video gives you the opportunity, of course, play back, rewind, fast forward as often as you wish. All right, and that just makes it so the lecture's shorter. All right, so I'm going to get started with some of the 4.7 homework on page 250 now. Okay, so how do I do a bunch of these things? All right, so number 1, sine of pi over 2 minus 5 pi over 3. Okay, so that's the sign of a difference. That looks like this one. So it's sine of the first, cosine of the second, minus the other way around, cosine of the first, sine of the second. So plugging everything in, sine of pi over 2, cosine 5 pi over 3, minus cosine pi over 2, sine of 5 pi over 3. Okay, so I draw myself a circle. Pi over 2 is over here. That's pretty easy. The ordered pair is 0, 1. Cosine of 5 pi over 3. So where is 5 pi over 3? It's over here. If I go all the way around the circle, that's 2 pi or 6 pi over 3. So 5 pi over 3, I back up 60 degrees. I'm here. Okay. Now notice how I always do this and this. Okay. I ask myself which one is halfway, the x or the y coordinate. Okay. That looks way more than half. That looks like it's half. Okay. So the x coordinate is a half. Y is automatically the other number. The other number is always radical 3 over 2. In this case, it's a negative. I'm in quadrant 4. All right, now I plug in. Sine of pi over 2, 1, y coordinate. Cosine of 5 pi over 3. So x coordinate here, 1/2. Minus cosine of pi over 2. Cosine of 90 degrees is 0. Times, well, once you have the 0, you don't really need this, but just for completeness sake, sine of 5 pi over 3 is negative radical 3 over 2. Not that it matters because you were going to multiply by 0 anyway. So that's gone. So the answer is 1 times a half or 1/2. Okay. So that's the idea behind that one. Okay, number 3, cosine of 7 pi over 12. Okay, give the exact value. By the way, notice that these are supposed to be done without a calculator. Even though I'm letting you have a calculator as a double check, you should work these out without a calculator. I never picked up my calculator. You should be able to do these without a calculator and drawing a unit circle. Okay, what is 7 pi over 12? Well, I can write it as 4 pi over 12 plus 3 pi over 12. And the reason why you want to do that is because those are both angles that I recognize. Right? 4 pi over 12 plus 3 pi over 12 is 7 pi over 12. But that reduces to pi over 3. That reduces to pi over 4. So this is now the cosine of a sum. Cosine of something plus something. I'm using this one, the top one. So it's cosine first, cosine second, minus sine of the first, sine of the second. So cosine pi over 3, cosine pi over 4, minus sine pi over 3, sine pi over 4. These are all first quadrant, so very nice. I know for pi over 4, both x and y are radical 2 over 2. Cosine pi over 3 is 60 degrees. I draw myself a 60-degree angle. Again, the x looks like it's halfway across. Y is more than half. So the ordered pair is 1/2 radical 3 over 2. So cosine pi over 3, x coordinate, 1/2. Cosine pi over 4, radical 2 over 2. Minus sine of pi over 3, y coordinate, radical 3 over 2. Sine of pi over 4, radical 2 over 2. Together, you have a common denominator 4. 2 times 2 is 4. 2 times 2 is 4 on the bottom. And on top, I have 1 radical 2 is radical 2, minus radical 3 times radical 2 is radical 6. So final answer is radical 2 minus radical 6 all over 4. Okay, so that's problem 3. Okay, and then, let's see. How do I do tangent of pi over 12? So what angles do I recognize for pi over 12? Now, pi over 12, you could say 4 pi over 3 minus 3 pi over 3. I'm going to try 3 pi over 12 rather, minus 2 pi over 12 just to get a different angle. Okay, 3 pi minus 2 pi is pi, and that reduces to pi over 4, and that reduces to pi over 6. Okay, and tangent is sine over cosine. So sine of 3 pi over 12 minus 2 pi over 12 divided by cosine 3 pi over 12 minus 2 pi over 12. That's pi over 4 minus pi over 6. Pi over 4 minus pi over 6. Okay, so you have to use the formulas for each. So you have the sine of a difference, sine of something minus something. That's the bottom one here. sine A cosine B minus cosine A sine B. And then I also have cosine of a difference. So that's cosine A minus B, cosine cos B plus sine A sine B. Okay, so plug those in here. All right, so work the numerator out. Sine of pi over 4 minus pi over 6. Sine of pi over 4 cosine pi over 6 minus cosine pi over 4 sine of pi over 6. Pi over 6 is 30 degrees. So I drew myself a 30-degree angle. 45-degree angle is here. I know they're both radical 2 over 2. 30 degrees, you know one of the coordinates is a half. So draw myself a 30-degree angle. I go like that and like that. Which one seems halfway across? Y. Y looks like it's halfway. That's more than halfway. So y gets a half. X is the other number, radical 3 over 2, which is 0.866. Definitely more than half. All right, sine of pi over 4, radical 2 over 2. Cosine pi over 6, radical 3 over 2, x coordinate. Minus cosine 45 degrees, radical 2 over 2, x coordinate. Sine of pi over 6, sine of 30 degrees, y coordinate, 1/2. Okay, once again, I have a common denominator of 4, so 4 is on the bottom. Radical 6 minus radical 2 over 4. All right, cosine of the difference. So it goes cos plus sine by formula. Okay. Both cosine and sine of pi over 4 are radical 2 over 2. Cosine pi over 6, x coordinate, radical 3 over 2. Sine of pi over 6, y coordinate is a half. Common denominator is 4, so radical 6 plus radical 2 over 4. All right, so we're ready for the tangent. Tangent is sine over cosine. So I take this thing divided by this thing. Here we are. And I showed you that trick before. These 4s can just cancel out. If you have a complex fraction, a fraction inside a fraction, you're dividing the top by 4, you're dividing the bottom by 4, you can just cross these out. So final answer, radical 6 minus 2 divided by radical 6 plus 2. And I'll let you stop right there. That's okay. All right, then use a double or half angle formula to determine the value of the trig function. Sine of 7 pi over 12. Sine of 7 pi over 12. That doesn't seem like anything we recognize. But if I double that angle, multiply that by 2, that becomes 7 pi over 6. I do recognize that. Okay, so what I want to do is double this angle. I'm using this formula. Sine squared of theta equals 1 minus cosine 2 theta over 2. So if I go from here to here, I double the angle, multiply by 2. All right, so if I double 7 pi over 12, I have 7 pi over 6, which is what I want. Okay, so 1 minus cosine 7 pi over 6 divided by 2. Okay, so the sine of 7 pi over 12 is the square root of all that. Okay, and let me think of where 7 pi over 12 is. 6 pi over 12 is right here. So 7 pi over 12 is a little bit more. It's in the second quadrant, so it's positive. So I had to think about whether it's plus or minus here. Okay, so I want the positive. Okay, 7 pi over 6 is over here, 30 degrees off of 180. Figure out which one is a half, either x or y. It looks to me like y is halfway down. So negative radical 3 over 2, negative a half. Okay, so they ask for the cosine of 7 pi over 6, negative radical 3 over 2. So by formula, it's 1 minus this thing, 1 minus a minus radical 3 over 2, or 1 plus radical 3 over 2. That's essentially the answer. You can make it look nicer if I multiply top and bottom by 2. Okay, so if I multiply this by 2, I have 2 plus radical 3 the bottom becomes the square root of 4, and the square root of 4 is 2. So I'll just leave it like this. That's as good as it gets. It's not very good, as you can see. I got a square root inside a square root, but that's just the way it came out. So I guess I got to live with it. Okay. Okay, play the same trick with number 9. Cosine of 5 pi over 8. Again, I don't recognize 5 pi over 8, but if I multiply this angle by 2, 2 cancels 8, it'll be 5 pi over 4, and I do recognize 5 pi over 4. Okay, so I want to double that angle. So I'm going to take advantage of this formula. Cosine squared theta is 1 plus cosine of 2 theta over 2. Okay, so one more time, I have 5 pi over 8. If I double 5 pi over 8, 2 times 5 pi over 8, that's an 8 there. You get 5 pi over 4. Okay, the other thing I noticed, I did put a minus sign here. I know the answer is negative. Where is 5 pi over 8? Okay, if I look at my unit circle, this is pi over 2, which is 4 pi over 8. Okay, 4 pi over 8. So 5 pi over 8 is a little bit more. I'm in the second quadrant. Second quadrant cosine is negative. So automatically, I'm expecting my answer to be negative. All right, so cosine squared of theta by formula is 1 plus cosine 2 theta over 2. So I multiply this angle by 2 to get this. So cosine squared, notice the formula has cosine squared. So how do you get cosine? Just square root. So cosine squared of 5 pi over 8 is 1 plus cosine of twice that angle, double that angle, divided by 2. Then I do the square root, and I need the negative because I've already established this as a second quadrant angle, so I want the negative. Okay, cosine of 5 pi over 4, that's in the third quadrant, so that's negative radical 2 over 2. Right, so 1 plus a negative radical 2 over 2 divided by 2. It's a negative. Okay, that's, again, essentially it. I'm going to multiply top and bottom by 2 here just to make it look nicer. So the bottom becomes a square root of 4, which is regular 2 outside. And just like the other one, 2 times 1 is 2. Negative radical 2 over 2 times 2, the 2's cancel out. So I have 2 minus radical 2 underneath another square root, and the whole thing is divided by 2. And I want the negative of the whole thing. Okay, so there's a lot to this one, as you can see. All right, then 13. There's a lot going on. It says cosine of t is 4/5. T is between 0 and pi over 2, first quadrant. They want you to find all this stuff here. Okay, so I'll do 13. Let's do 15 on your own, perhaps. Okay, cosine of t is 4/5, quadrant 1. Now, remember, whenever you have cosine, you can always find the sine by using this, and vice versa. Anytime you have the sine, you can figure out the cosine. So sine squared t plus cosine squared t is equal to 1. And sometimes you see this formula with the cosine squared first. That's okay. So sine squared t plus cosine of t is 4/5. 4/5 squared equals 1. Square this, I have 16 over 25. Subtract from 1. 1 minus 16 over 25, 9 over 25. Square root, square root. I'm in the first quadrant, so sine of t is 3/5. Okay, so that's what I want. So I now have cosine of t is 4/5, sine of t is 3/5. I will need this for the rest of the stuff. So from here, I'm just plugging into formulas. So cosine of double line angle, cosine squared t minus sine squared t. Cosine of 2 theta, cosine squared minus sine squared. So cosine of 2t, cosine squared t minus sine squared t. So cosine squared 4/5 squared minus sine squared t 3/5 squared. So that's 16 over 25 minus 9 over 25 Answer is 7/25. Sine of 2t. Okay, 2 sine t cosine t. Sine of double an angle. Sine of 2 theta, 2 sine theta cosine theta. So it's 2 times sine of t, which was 3/5, times cosine of t, which was 4/5. So 2 times 3/5 times 4/5. Put them all together. 2 times 3 times 4 is 24. 5 times 5 is 25. So the answer is 24/25. Okay, cosine of t over 2. Okay, first thing I noticed is t was the first quadrant angle, they told me, 13. T is between 0 and pi over 2, 0 and 90 degrees. So if I cut it in half, something between 0 and 90, I'm now between 0 and 45 degrees. It's still quadrant 1, right? So again, t is between 0 and pi over 2. Think in degrees if you're more comfortable. T is between 0 and 90 degrees. Cut it in half. Now it's between 0 and 45 degrees. Still first quadrant. Okay, so that means cosine and sine are still both positive. All right, so I'm going to use this formula. Cosine squared of theta is 1 plus cosine 2 theta over 2. So cosine squared of t over 2 is 1 plus cosine t over 2. Double this angle and you get that, or you take half of that angle and you get that. Okay, so these are really the same formula. Okay, to go from there to there, you double the angle. To go from there to there, you double the angle. Or if you go from there to there, you take half the angle. Right, half of 2 theta is theta. Half of t is t over 2. All right, so jumping over here now. So cosine squared, ignore the square root temporarily. So 1 plus 4/5 divided by 2. Okay, we had cosine of t was 4/5, right? So 1 plus 4/5 divided by 2, that's 9/5 divided by 2, which is 9/10. Remember, dividing by 2 is the same as multiplying by a half. So 9/5 times a half. Or again, I think I showed you this trick. You can just slide that 5 down with the 2. If you have a fraction like that, bring the 5 down. 5 times 2 is 10. Then you take the square root of both sides. So cosine of t over 2 is radical 9 is 3. 3 over radical 10. Okay, you can leave it as 3 over radical 10. If you want to rationalize the denominator, multiply top and bottom by radical 10 over radical 10. 3 radical 10 over 10. Okay, do the same thing with d, sine of t over 2. Okay. So that's an example of this formula. Sine squared theta equals 1 minus cosine 2 theta over 2. Okay, so again, to go from here to here, you multiply by 2. Or to go backwards, if you want to go from here to here, you divide by 2. So if I put t over 2 here, if I double it, I get t. That's what I want. Okay, so notice this is an application of this rule. If I double the angle t over 2, I get t. Double theta to get 2 theta. And I want this because I know cosine of t. I already have cosine of t as being 4/5 over here. Right, so sine squared of t over 2. Again, that's sine squared. I have to do the square root later. 1 minus cosine of t, 4/5, divided by 2. 1 minus 4/5 is 1/5. Divide that by 2, or multiply by a half, or slide the 5 down with the 2, 1/10. Okay, so sine squared of t over 2 is 1/10. So take the square root. I already established that I'm in the first quadrant, so I don't need to do a minus, plus or minus. So sine of t over 2 is the square root of 1/10, or 1 over radical 10. I'll let you leave it like that. Or again, you can rationalize the denominator by multiplying by radical 10 over radical 10, but that's the idea behind that one. Okay, so that's how you do 13. All right, then how do you do some of these problems? Use the sum or difference formula to verify the identity. Okay, so just use the formula to verify the right-hand side. it's like a trig identity that you did in trig, hopefully. Okay, so I'll show you one of those perhaps. Okay, 17, sine of t plus 3 pi over 2 is the same as negative cosine t. So I use the formula for the sine of a sum, sine of something plus something. Sine of A cosine B plus cosine A sine B. Okay, so sine t plus 3 pi over 2 is sine of t cosine 3 pi over 2 plus cosine t sine of 3 pi over 2. And mind you, as I'm lecturing, I know I might be going kind of fast, but this should not be the first time you've seen it. Okay? Now, if you had never seen any of this stuff before, you never took trig, then I would go much slower. But since this should be just kind of review, oh yeah, I saw this before, I'm supposed to go faster. This should not be the first time you've seen this stuff. Okay, so 3 pi over 2 is right here, south pole, as it were, 0, comma, negative 1. So cosine x coordinate at 0. So we multiply by 0, just forget about it. Sine of 3 pi over 2, y coordinate is negative 1. So cosine t times negative 1, negative cosine t. So that's that. Okay. All right, so that's how you do this bunch. Then the next one I was going to show you is 25. So I showed you 17, you do 19 and 21. 25, use a half angle formula to rewrite the given expression. So it involves the sum or difference of only constants and sine and cosine to the first power. So they're saying don't have a fourth power, don't have a square, only first power. Okay, so I'll show you 25. Sine to the fourth. Okay, that's sine squared, right? And now I use the formula for the sine squared of x. 1 minus cosine 2x over 2. So sine squared 1 minus cosine 2 theta over 2. You've got your cheat sheet. Just look for the right formula to substitute. Okay. And so where am I now? Okay, so 1 minus cosine 2x over 2 squared. Okay, 2 squared is 4 on the bottom. And now I square the top. 1 squared is 1. The middle term is minus 2ab. So minus 2 times 1 times cosine 2x plus cosine squared of 2x. Okay. So I have this right now. All right, and I decided to distribute the 1/4 because it's going to get messy. So 1 divided by 4 is 1/4. Minus 2 over 4 is negative a half cosine 2x plus 1/4 cosine squared of 2x. Okay, you can see I goofed here. Leave that alone, leave that alone. Okay, cosine squared of 2x. So I got it here. Cosine squared of theta is 1 plus cosine 2 theta over 2. So if I'm going from here to here, you take this angle and double it. You multiply that by 2 and put it over here. Now, the angle was 2 theta, or sorry, 2x. So what is double of 2x? What's twice 2x? 4x. I forgot to put the cosine the first time. So cosine squared of 2x is 1 plus cosine, double that angle. 2x is an angle, it's a legitimate angle. Double it is 4x divided by 2. Okay, that's what they're asking for. Get it down to just first degree. No squares, no cubes, no fourths. Okay, so now I just got to clean that up. That becomes 1/8. Leave that alone, leave that alone. 1/8. And leave that alone, leave that alone. Distribute 1/8 plus 1/8 cosine 4x. And now I just add 1/4 plus 1/8. 1/4 is 2/8. 2/8 plus 1/8 is 3/8. All right, so final answer, 3/8 minus 1/2 cosine 2x plus 1/8 cosine 4x. Okay, so that was quite a bit for problem 25. And yes, remember, we're skipping 27 and 29, so I won't show you anything for that one. Okay. All right, going a little bit out of order here. I want to show you that, but now I'm going to go back and do 21. Sine of a difference. Sine of pi minus t is the same as the sine of t. Okay, so just use the formula. Sine of pi minus t equals sine of t. So this is the formula for the sine of a difference. Okay, so sine of a minus b. Okay, I rewrote it here. Sine of a cosine b minus cosine a sine b. So by formula, sine pi cosine t minus cosine pi sine of t. Okay, draw my unit circle. Pi is 180 degrees. The ordered pair is -1, 0. So let's see. Sine of pi, y coordinate, 0. Cosine of pi, x coordinate, -1. So it's 0 times cosine of t, that cancels out, that's 0, minus a -1 sine of t, and two negatives make a positive. So the answer is sine of t, which is what was expected over here. Okay. All right, then let's see. We have some identities. Verify the identities. Okay, that means show that the left-hand side is always equal to the right-hand side. Left side and right side are always the same. So you're not solving for x per se. For these problems, you are solving for x. Here you're saying the left side is always equal to the right side. Okay, so I'll show you a couple of those. 31, 1 minus cosine squared x times secant squared x equals tangent squared x. Again, please notice the difference between the way they write it and the way that is normal, quote unquote, to write it. They wrote it as cosine x squared. I mean, I can understand why you do that. Some of you who have a calculator that allows this stuff, you would have to type it that way. Okay, the square like that. But the usual way from trig to write it is like so. So cosine squared x, secant squared x, tangent squared x. Okay, show that the two are equal. All right, now here are my ground rules for doing a proof. Now you probably did some trig proofs in trig. Okay, I've got my way of doing it, and sorry, you got to do it my way, otherwise I don't accept it. Okay, by the equal sign, you can draw a line here. This is a barrier, which means you're not allowed to cross over until they're equal. Okay? So operations that are not allowed are multiplying both sides by cosine squared, for instance, or adding 1 to both sides. That's not allowed. Okay? You can work on the left side. You can work on the right side independently, and you keep going until they're equal. As you can see, I got that happening here. Keep going until they're equal. All right, so tangent squared is sine squared over cosine squared, and that's about all I'm going to do on the right-hand side. So I'm looking for sine squared over cosine squared over here. All right, 1 minus cosine squared x, that's equal to sine squared x, right? That's a variation of sine squared plus cosine squared equals 1, right? If sine squared plus cosine squared equals 1, that means 1 minus cosine squared x is sine squared x. And then secant squared x, that's 1 over cosine squared x. What happens when I multiply these two together? Sine squared x divided by cosine squared x. And there they are, they're equal. Okay. Notice I never assumed the left side and the right side were equal. I did some work here, I did some work here, and lo and behold, they are equal. Okay, so what am I allowing? If you draw a line down the middle like this, you can work on the left side or the right side independently, but you can't cross until they're equal. So that means you're not allowed to multiply both sides by 2, for instance. If you look at 35, I seem to contradict myself, okay, but there's a good reason for that. Okay? There's really nothing to do with cosine of x. All the action seems to be on the right-hand side, so I'm not going to touch this side. Or you can see I take it back. I did draw a line, but there's really nothing to do on the left side. Cosine x is as good as it gets. So all the action is going to be over here, right? Here, I did work on both sides. So if I am working on both sides, I'll approach it like so. Okay, so for 35, and so this one, cosine x, that's already pretty easy. Nothing to do. So all the action is on the right side. Okay, sine x, sine 2x, plus cos x, cos 2x. Okay, so there's my barrier line. Okay, leave that alone. Sine of 2x by formula, 2 sine x cosine x. Just take it right off your cheat sheet. Cosine x plus cosine of 2x by formula, cosine squared x minus sine squared x. All right, somehow I got to get all that to be the same as cosine x. Let's just multiply it out and see what happens. So if I distribute 2 sine squared x cosine x, that times that times that times that, plus cosine cubed x minus cosine x sine squared x, if I distribute all this. Okay, so now I have all this stuff. Okay, these three have a common factor of cosine x, right? Cosine here, here, and here. So factor out the cosine x, and what's left behind? 2 sine squared x plus cosine squared x minus sine squared x. Okay. And these two combined, 2 sine squared x minus sine squared x is just sine squared x. So I have cosine x times sine squared x plus cosine squared x. That's perfect because that's equal to 1. That says a 1 there. So I have cosine x. So that's it, and we're done. Okay. All right, so that's that. All right, and I think I've done enough for today. So I'll stop here. I just have a couple more problems at the end, and I'm done with 4.7. So looking at the schedule, or rather this, I'm almost done with 4.7. I'll finish 4.7 tomorrow and start 4.8, which is on the inverse trig functions. Okay, so let's check our calendar again. Calendar-wise, I was supposed to only be on 4.6. So again, I'm a day ahead, but I forgot to put down 4.9 here, so maybe I'm not as far ahead as all that. Okay. All right, so tomorrow I'll do the last couple problems from this section and start a new section. Okay, so stop the share. Let me check the chat. Nothing in the chat. Okay, so I'll take any questions, and if you don't have any questions, we're done for the day, folks. Okay, so anybody have any questions? All right, hearing none, then we will adjourn. All right, that's it for today, folks. Have a good day. We'll see you all tomorrow. Okay, bye, everyone.